how you try section, you're going to again try out the compound inequalities of all three types and write your solution in number line interval and set notations. Remember, once you're done, then you can continue the video and look at the solution for these problems over here. For the first one, we're going to again work with one inequality at a time. So here, if I want to get the variable term by itself, I'm going to go ahead and subtract 20 on both sides of the first inequality. And I'm going to omit the step where I'm subtracting 20 to write it out. And if I subtract 20 on the left side, I would have negative 4x greater than if I subtract 20 on the other side, I would get negative 27, because negative 7 minus 20 will be negative 27. And here, if I want to get x by itself, go ahead and divide by negative 4. And anytime you divide or multiply a negative number, remember to flip the direction of inequality symbol. So we would get x is less than 27 over 4. For the other inequality, same thing as before, I'm going to get 14x by itself by adding 13 on both sides. Adding 13 on the right side will give me positive 8 as a result. And with this, we can go ahead and divide by 14. Here we would get x is greater than or equal to 8 over 14, but you can also reduce a fraction to be 4 over 7 if we divide 2 on both sides as a result. And now if we want to put everything together, because it's connected by and, we are looking for the part where the two overlaps on the number line. So we have 27 over 4 and 4 over 7. Again, try not to use a calculator, but use your understanding about fractions. In this case, 4 over 7 we know is less than 1. 27 over 4, because the numerator is larger than denominator, we know is greater than 1. So naturally we can put 4 over 7 to the left of 27 over 4 as a result. And just having this number sense will be helpful in general to kind of have you proceed further along outright and save you time as well for our process. And here we want to look for where x is greater than or equal to 4 over 7. So we are looking at this part. And then we're also looking at the part where x is less than 27 over 4. So we would have 27 over 4 and everything to its left. If we were to find out where they overlap, it will be this little highlighted area over here. And again, choose whichever notation you're most comfortable with to start with. And I like to write the interval notation first in this case, because I know the left bound is 4 over 7, and it's inclusive because we have a bracket on the left, and it goes all the way to 27 over 4, which closes with a parenthesis. With this information, we can write the set notation as x such that 4 over 7 is less than or equal to x less than 27 over 4. Lastly, if we want to use a number line notation, we can just simplify the representation a little bit. With a number line we already have, we get 4 over 7, 27 over 4, and we want everything in between. Starts with a bracket and ends with a parenthesis, which matches exactly what we have for the interval notation. And that's how we would solve the first one. Whenever you're ready, we can move on to the second one with a similar process of solving individual inequalities first. To get x by itself, I'm going to add 20 first in the first inequality on both sides. And as a result, I would get 5x is greater than or equal to positive 16, because negative 4 plus 20 gives us 16. And to isolate x completely, I'm going to divide by 5. As a result, we get x is greater than or equal to 16 over 5. On the other one, we would want to add positive 15 on both sides over here. And I notice I copied the round number on the right side. It should be positive 15. So if we go ahead and add 15 on both sides, we would get negative 4x is greater than or equal to 30, because 15 plus 15 gives us 30. And with this, to get x by itself, go ahead and divide by negative 4 on both sides. We will have x is less than or equal to over here, because we're dividing a negative number. And also along the way, we would get negative value on the right side, and we can go ahead and divide 2 on both sides. So we get 15 and negative 2 over here. So as a final answer, we would have 15 over 2. That's negative. And with this information, we're going to, again, think about the connecting word being or and how this affects the final answer. And this one, it might be a little bit easier to see because we have a negative number versus a positive number over here. We get x is greater than or equal to 16 over 5, which is positive. So it's definitely the larger number of the two. So if it's greater than or equal to, we just include a bracket, and we want to go further to the right. And for the other one, x is less than or equal to, so we want to take the left side of that number with a bracket as well. And because they don't overlap at all, and we have a connecting word being or, so this result is going to be the number line notation for our answer. We don't have to clean up anything. It's already as simplified as this can be over here. So that will be our number line notation automatically. And with this information, that means we can also just write the set notation pretty quickly as two separate inequalities connected by or. And again, I like to write the smaller one first over here. X is less than or equal to negative 15 over 2, or x is greater than or equal to 16 over 5. That's how we write it out. Lastly, for the interval notation, whenever we have two intervals, we have to connect by union for this or situation. And the first interval is starting from negative infinity, ending at negative 15 over 2. Inclusive, we can use union for connecting the interval from 16 over 5 all the way to infinity as a result. So that's how we write the final answers in all three notations. Again, whenever you're ready, we can move on to part C. For part C, that's a three-part inequalities again. Remember, whatever we do to one part, we're repeating it to the other two parts with the same operation. And now we have negative 3 minus 5 over 4x in the middle. So the first part we want to do is still isolate the variable term by itself. So that means I want to get negative 5 over 4x by itself. So that tells me I want to get rid of the negative 3. Because it's a negative 3, I'm going to add 3 on all three parts of the inequality. And because this is somewhat new to us, I'm going to write out the steps a little bit more. So I'm going to add 3 on all three parts. Initially it's negative 3. If I add 3, I can go ahead and cancel things out to just have the variable term left. And this is greater than or equal to negative 23. I'm going to move this a little. Plus 3. And as a result, we get 15 is greater than negative 5 over 4x. That's greater than or equal to negative 20 over here. And this is already a lot cleaner than what we started with. And next, to get x by itself, we can multiply the reciprocal of our coefficient in front of x. And as a result, I'm going to multiply negative 4 over 5 on all three parts over here. And I'm going to just make a little bit more room over here. So I have enough room to write the fraction out. So here I'm going to multiply negative 4 over 5, here negative 4 over 5, and here negative 4 over 5. Remember, we choose that number because it's a reciprocal of our coefficient. And as a result, in the middle, we can see the fractions cancel each other out to just leave a 1, which means it's 1x or just x. And on the left side, we see that 15 and 5 can cancel each other out with a 3 on top and 1 on the bottom. So we would end up with a negative 12 over here. Lastly, if we have the right part, the last part over here, the 20 and 5 again cancel each other out, and we would have a 4 over here and a 1 over here. And as a final answer for the last part, we have 4 times 4, which is 16. And the negative signs again cancel each other out. And remember, because we're multiplying a negative number, we have to flip the direction of the inequality symbol. Hopefully this one's pretty easy to catch, because if you didn't flip, it wouldn't make sense that x is smaller than a negative number and greater than a positive number. So that would be our final answer. In this case, the result is still a 3-part inequality, so if you want, you can write this out as a set notation pretty quickly, where we get negative 12 is less than x, less than or equal to 16. And with that, we can go to the number line notation. So notice I'm still trying to get you to try out the different orders as to what notation you want to start with. It really doesn't matter as long as they're conveying the same information. You should get the same correct answer no matter which order you work with. And we are going from negative 12 all the way to 16 with negative 12 excluded, 16 included over here. And lastly, for the interval notation, we would go anywhere from negative 12 to positive 16 as a result. So that's how we can find the solutions for compound inequalities of different types.